I thought that perfect on things that
Any questions?
Yes.
Wow,
Is it
what a
possible-
surprise.
Is it possible that you can do a practice problem where it shows the theta, the theta's involved? So it's like a projectile almost, I think, like this one.
Where you have to find theta, or you're given theta?
Or just something that has to do with this, like, up to you whether which one.
I'll do a standard one for us. As far as the quiz is concerned, I don't think there's any of the homework problems where you're trying to find the angle.
Okay, so like finding the other part.
Let's make it 53 degrees and 50 meters per second from a cliff that is, we'll make it big, 100 meters tall. And I want to know, where does it land? So this type of thing that you're looking for? What's the first step?
Identify our knowns.
It's what?
Identify our knowns.
Okay. What do we know? I'm trying to play to the audience, not just Ibrahim. So what do we know?
Vertical displacement is 100 meters.
All right, so let's set up our
Horizontal.
chart. So you 100 meters. So what did you just establish?
The vertical is the height.
Yeah, you did more than that.
It's a positive.
All right. Remember, we're dealing with vectors. You said 100 meters.
Yes.
So you just established.
That down is negative.
Oh, that's not what you made it positive when you said 100 meters.
Okay.
Do you want down to be positive?
No.
Okay.
It's positive.
So what you're saying is that you were lying to us before, is that?
A little.
Okay. All right, so this Gigi wants up to be positive, and I'll go ahead and establish to the right is positive. So I got my I hat and my J hats. Set up my, let's see, the I, and final, A, and T. All right, so negative 100 meters. All right, we're on a roll.
The initial velocity for vertical is gonna be 50 sine 53. Oh, I got it. So,
The horizontal one would be 50, cosine 50.
And if you ever get into that moment where you're suddenly blanking and going, wait, which one's sine, which one's cosine? If you try to draw a 53-degree angle, so 90 degrees, it's 90, 45. 53 is bigger than 45, so I'm just gonna draw an, still an acute angle, an angle more than 45 degrees. And if I do the sine and cosine of 53 degrees, cosine is gonna be the smaller one. If you calculate it out, use a calculator or slide rule, whatever you happen to be using. The smaller one would go with the smaller side. All right, we know two other things.
Is the acceleration not going to be, if we're talking about Earth?
Sure, let's put it on Earth.
so to think about,
Ali, you were saying?
The acceleration is 9.8 meters per second squared.
negative.
Yes, the negatives are crucial here. Where does that go? All right, negative 9.8 meters per second squared. And we know one other thing.
The
Horizontal acceleration is 0 meters per second squared.
All right. let's just go ahead and make that R. All right, so we're given this. We know that time is the binder, it's the glue, it's the adhesive. So what do we do in order to find time? Okay, any particular one?
The displacement equals the initial velocity times time plus half of the acceleration times time.
And, yep, this is written on there. And so it becomes plug and chug, negative 100 is equal to, let's see, so sine of 53 degrees, about 0.8, so this is somewhere around 40, I'm just gonna make it 40. And this is approximately 30. The 53-degree angle, classic for physics, is get the 3, 4, 5 triangle. Okay. All right, color. I don't want that. I want black. Apparently, I'm not allowed. So we have negative 100 equals 40t minus 4.9t squared. The 1/2 a is where I get the negative 4.9. Now what?
Quadratic formula then. Well, do the thing. You have to
Do the thing?
do the thing. What? Take the 100, put it on the other side.
Well, apparently this doesn't want to do anything right now. I'm so glad they replaced it. All right, so how much for that first? Do that. We'll try the classic. Turn it off, turn it back on. All right, so I'm gonna put for whatever reason, again, chocolate stars, I like my highest polynomial order term to be positive. So 4.9t squared minus 40t minus 100 equals 0. Again, all the math sees is a parabola. So I am expecting two answers. One of the answers will be positive, one negative, and I expect the magnitude or the absolute value of the positive number to be bigger than the absolute value of the negative number. So, t equals 40 plus or minus the square root of 1600 minus 4 times 4.9 times negative 100 over 2 times 4.9. Yep, Pythagorean theorem's on there.
You mean the quadratic formula?
Yeah, what did I say?
Pythagorean theorem?
Yeah, that's not on there. Yes, quadratic formula's on there. You know, what are those math things? I just put down random math equations.
Let's see.
And the answers are. tension is mounting. Oh, let's see.
So, my first answer is 10.17. And my second answer is negative 2.006.
The average is around 4, which I would expect. The reason why I would expect it around 4 is that the midpoint, the peak there happens at 40 over 9.8. So if you remove that, you get the peak time, or the peak time. That's roughly 10, 40 divided by 10 is 4, which is roughly the average of those two, so something seems to be right.
So that's how we can check it.
It's a quick and dirty check. Those are times, that's not the actual answer. So 10.17 seconds, 10.17 seconds. And now what?
Now, we can use the same formula, except this time, we're plugging in the time.
Okay, same formula, let's plug it in the isolate. So R is equal to 30 times 10.17. That's meters per second times seconds. And so we end up with 305.1. Yep. I know what you're thinking. You're thinking, that's incredible. Can I actually be quizzed on something like that? I think we can arrange something. Any other questions on this or other questions?
What the quiz is this Thursday, or not the quiz, the test.
I think it's
I
Monday.
think it's next
There was
Tuesday.
good next Tuesday.
Oh, it's next Thursday.
Next
No,
Tuesday.
next Tuesday.
Next Tuesday. Oh. Phew, okay, I'll get him.
Could you do one of the serving a tennis ball one?
Serving a tennis ball one.
Yeah, the one that's on,
Any
Yeah, you
questions
have-
on this before I erase it?
You have to find the angle in that question that he was referring to.
All right, so my recollection is you have to clear the net.
yeah.
All right, so let's draw the picture. That net, I got ball being served from up here. You're trying to find, read the question, please.
Serving at a speed of 170 kilometers per hour, a tennis player hits the ball at a height of 2.5 meters and on angle theta below the horizontal. The service line is 11.9 meters from the net, which is 0.91 meters high. What is the angle such that the ball crosses the net? And will the ball land in the service box whose outline is 6.4 meters from the net?
And this was 2.5 meters.
Yes.
So it's served from a height of 2.5 meters at an angle below the horizontal. It has to clear the net of 0.91 meters, and the question is, and the net is 6.4 meters from either end. Is that right? All right. So, well, we take it as two parts. First, we need to figure out what the angle is. So the first part is I'm dealing with this problem. Trying to find the theta. So I hat, j hat, x, the final, acceleration and time. Just stick with the same convention. No, let's make down positive. J hat, I hat. So, what is the vertical displacement going to be?
meters, or negative 2.5 meters.
I mean, down positive, but it's not 2.5 meters because we're just trying to make it clear the net.
Oh, so subtract
Subtract it.
49.
Yeah, it's the difference between the 2.5 and the 0.91. So 2.5 minus 9.1.
Is 1.59.
The initial velocity, it was 117 kilometers per hour. We probably should get that in terms of meters per second, just so that we don't have to think about the units later. So, do a quick conversion, 117 kilometers per hour. How many seconds in an hour?
3,600 seconds?
So 3,600 seconds per hour. And meters in kilometer?
1,000?
And just to make sure, I'm gonna get meters per second, kilometers cancel out, hours cancel out. I'm left with meters on top, seconds on the bottom. So it roughly comes down to 117 divided by 3.6. Which is
32.5.
So this becomes 32.5 meters per second sine of theta, and 32.5 meters per second cosine of theta. Very similar to what we've done in the past. We know 3 other pieces of information.
The acceleration due to the acceleration due to gravity is positive 9.8 on the iron.
On the I-hat.
On the J.
Is that your final answer?
Busted in.
All right. 9.8 meters per second squared. So we're all making the assumption that Earth is the only place tennis is played.
I'm assuming if you play the companies.
2 other pieces of information.
I had a 0 for acceleration, meters per second squared.
1 more piece of information.
Horizontal displacement.
Yes.
That is something.
Yes,
Something-
I will agree.
Would it be something plus 6.4?
We're all concerned about is just 2 here.
Okay,
Because when at this horizontal displacement, we have that vertical displacement.
So would we use 6.4 to find?
Yes, very much so.
Would we use, could
6.4 meters. The net is in the middle. If it's 6.4 meters to that boundary, 6.4 meters to this boundary, I'm assuming he's serving from the back line. It might even state it. Now, for you tennis purists, they do stand behind the line. It might be, 6.5 meters in real life. We're gonna go with 6.4. All right, so what do we know? What can we find?
find the time? No, we can't find it. Maybe we can find the time. I don't know. We'll see.
you could find it, you could solve for, wow. I guess we're looking for the angle,
Yeah.
so,
So I was mistaken earlier when I said we didn't have any problems that you're solving for the angle. Well, if in doubt, we got our trusty and true delta x equals VIT plus 1/2 AT squared. So why don't we start out with that one just to see where that takes us. So I've got 6.4 is equal to 32.5 cosine of theta times time. Plug it into I-hat stuff, plus 0. And we have 1.59 equals 32.5 sine theta times time plus 4.9 t squared.
In this instance, are we gonna end up using a trig function?
Trig identity?
Trig identity?
Yes. I was thinking that there was a simpler way of solving this one, but, you know, this will get us there. No, it's the same process we've been doing. All right, so I know that sine squared plus cosine squared is equal to 1. If I divide by cosine squared, I get tangent squared plus 1 is equal to 1 over cosine squared, which, for the trig fans, is a secant squared. So we're going to take the first one, solve for time, plug into the second one. And we shall all be better people for having had the experience. So from the first one, I know that time is equal to 6.4 divided by 32.5 cosine. And I'm just going to do my abbreviation of C for cosine and S for sine, just because I don't feel like writing it out. Plugging into the second one, 1.59 is equal to 32.5 sine times 6.4 over 32.5 cosine. S. Plus 4.9 times 6.4 over 32.5 cosine. Square that whole thing. I've got sine over cosine, which is
Tangent.
32.5 cancels out with that one, so I'm left with 1.59